Hey everyone, welcome to the Stateless Implementers call number 37. I will share the agenda in the chat. As a brief summary of the agenda, we have the usual team updates, and then we'll have two presentations. One of them is an impact analysis of VIP 7736 by Han, and then Carlos will do a presentation of the new BlockNet website and related metrics. So yeah, let's start with team updates. I can start. I've been mainly working on more CKE VM tests coverage. I'm starting to think about them more related to tools that will help us figure out potential gas repricings rather than fully like worst case scenarios. So it's a kind of a bit of a mix between the two. But yeah, because like we are already starting to cover a lot of not like a lot of opcodes that clearly won't be like worst cases, but I think they will be still very useful to understand relative costs between opcodes and see if the current gas codes make sense. So yeah, I mean focus mostly on that.
Yeah, I guess I'll go. Not much to announce on my side. Just work on doing the binary tree. Well, the implementation is done and matches what Ignacio has done. But now I'm trying to fill the test so that other people can see if we agree, so that we can, hone in on an implementation. I know Karim wants to do the next shadow fork with binary trees, so it would make sense to agree on that. I was also doing a bit of work on the Pythonification of EIP 4762. So yeah, Joachim, Gabriel, and Louis gave me some feedback. So thank you guys for that. It's a bit slow in the integration because there's always plenty of consequences. But yeah, it was very useful. I'm glad I asked for feedback because it was needed. Yeah, I think that's pretty much it for this time.
I'll go next. So from my side, I've been basically coding the spammer use cases or scenarios for bloating, in particular EOA to EOA transfer, funding with minimal way, plus then delegate authorizations on a batch format, and then also maximum code size contract deployment. Finally, I've added also next code size base attack to force the node to read as many bytes as possible, paying as less as possible. The rest of the attacks will likely require manipulation of the node or the database directly, so waiting on those. And on the other side, I've been also working on the bloatnet, which I'll showcase later. Not much to say aside from the fact that it's mostly ready, pending to integrate Grafana interfaces from most of the teams. If the thing is easy, if there's too many issues with privacy and permissions and all that stuff, I guess we will just post a link and that's it.
On business side, so I was working on the transition. So I'm trying to set up a real shadow fork with the Ethereum package, not just following Hoodie, but really creating blog, etc. For the moment without proof, but just create blog like that. So the whole stack is ready, but I had some performance issue with Verkel during block creation, so it was a little bit difficult to do the shadow fork with Verkel. So I decided to not really waste time optimizing Verkel since we want to switch to binary tree, and I want to directly use binary tree for the next shadow fork. So I'm trying to see with Thomas We are trying to propose the first implementation of the binary tree maybe this week or next week. And when it will be ready, we'll try to pass the test that Guillaume will create. And when it will be okay, I will continue to work on the shadow fork directly with binary tree. I will start with Hoodie, and when Hoodie will work smoothly, I will be able to do the same test for mainnet. So why I'm trying to do this kind of real shadow fork like that, other clients, I think it will be more easy for other clients to join, to test, to verify the state root, etc. So yeah, still working on that.
Anyone else wants to give an update? Okay. So next we have the presentation from Han regarding EIP 776. So Han, whenever you are ready.
All right, I'll share my screen. All right, cool. Yeah. So today I'll like to quickly share about one of the analysis that I've been doing for EIP 7736, basically answering some of the questions in regards to how effective this proposal is, and also to answer some of the key questions that we have for state expiry in general. So as a recap, or for those who are not too familiar with 7736, it is relatively simple proposal that works pretty well with Workle, and perhaps also in the future with binary as a state expiry proposal. So how it works is that at the leaf level, we basically add an additional metadata. Here I call it period, or you can call it expiry epoch, or it's basically like a timestamp to denote if like the last access for a given state. So this period, this metadata will be used to determine if a given stamp is expired or not. So that's pretty much all you need to know about this proposal for now. So since we have this proposal, I would like to know if the effectiveness of this CSPRA solution. So I did a bunch of experiment. So for the experiment setup, I use Geth. I basically do a full sync from about block 70 million to 21 million. So this is about one year and 5 months worth of full syncing. So during this period, I basically record the last access block number for each key value pair every time a read or a write event occurs. So basically for every state access operation. So now the first question that I'd like to answer is how many accounts and slots were accessed. So from my analysis, during the 1 year and 5 months, only 29% of the total accounts were accessed, and only 23.5% of the total storage slots were accessed. So from this graph, or from these two graphs, you can already see that a significant chunk of the state is still it hasn't been accessed for a long time. So that's one. And the second question is how many stamps were expired. So expired here means that we can define the expiry, how long we want to consider for the expiry period. But in my case, I consider a year. So expiry means that if it hasn't been accessed for at least 1 year, then it's expired. So for this question, the answer is 83.5% of the total stamps were expired. So this matches the answer that we have for the first question, since we have a huge chunk of the state that is considered that hasn't been accessed for a long time. So it makes sense for us to have like huge significant proportion of the stamps that are expired. Yep. And the third question is in Geth, how much storage space can we save? So ideally, we want to get like the before and after applying state expiry on Vocal directly. But due to time constraints, I only compare it on the flat key value storage in Geth. So in a normal circumstances, we have about 107.3 gigabytes worth of flat key value storage in Geth. Let's say we do the expiry and then we prune away all the expired state, then the final result is about 26.4 gigabytes. So effectively reduce the flat key value storage by about 81 gigabytes. So that's still quite a lot. So again, in regards to the vocal, that will be like a to-do in the future. And the last question that I'd like to answer is how much storage space can we save with this proposal? So the good thing about this proposal is that it's simple. However, the downside is also that it only expires the leaf nodes. So that means when it comes to comparing the storage space, we can only compare the storage space of in regards to the leaf values. So for this, the result is basically we reduce the value storage size in Vocal from about 45 gigabytes to 5.7 gigabytes. I see a hand raise.
Yes. Can I ask
Yes.
a question, or if it's fine?
Yeah, since you already raised, then please go ahead.
Okay. I have one question, like in the previous slide that you show the space about after the state. Yeah, like this one. With the normal and the state experiments, like statelessness. I have one suggestion is that like I am actually introduce myself. I'm Chandra Sama, currently visiting researcher at Kishon Group in security privacy domain. So we are achieving the privacy on GK rollup. Soon our paper is came out. But in my literature review, I find one thing is that like in the like stateless expiry, even we use like I have the one paper to show that like if we use the DST means like we will actually transmit the data through the DST. I am not exactly remembering that term. So even we got more lesser space to save. So means like we are getting also less than 26 with the state expiry model. So I will show the literature with you guys. So like we can think about also for the storage space if we like distribute the ancient data through the distributed hash table. So I will show that paper. Okay.
Yeah, that's cool. I mean, thanks for working on the same topic as well, and please do share the literature or the paper that you have with everyone here, and we can take a read. Yeah, but yeah, would love to learn more about your results once I read the literature. But yeah,
Yeah. Could you
have
share the
any-
like emails
Yes.
like where I can show the paper?
you can just
Because
share
I'm
it
the
here in the
first
chat.
time in the meeting. Because I am the first time in the meet, so that's why I'm asking. But I have loved to Ethereum ecosystem last 2 years, working on rollups rather than layer one. But now I am transiting to work on both like rollups and layer one. My mission is like achieving privacy with scale. So, but I have like contributing as much as I can contribute to different space. So, love to connect you.
Right.
Thank you for giving me chance.
Right, yeah, just share your link in the chat and let's continue with the presentation.
Okay, thank you.
Yeah, thanks for sharing. So let me just continue quickly. Yeah, so that's pretty much it on the result side. So I'd love to get into discussion. So as shown just now, it's pretty obvious that a significant proportion of the state is still. And so that's good news. The bad news is that 7736 doesn't save much storage space in terms of the vocal tree architecture because we are only targeting the leaf values. But the leaf values are relatively smaller than the other parts of the component in the state. So namely especially the intermediate nodes. So one of the more important performance bottleneck that we have for EL clients is this IO for intermediate nodes. So for MPT, I think it will be the same for MPT, for vocal, and also for binary. So it's not addressing that part. So the benefit that we can get for this proposal is only, I would say, primarily on the storage space. But if we can extend this proposal to also prune away the intermediate nodes, that would, I think, significantly improve the performance for EL clients. So that's another thing to look at. And also another crucial thing to look at is also I would say all of the state expiry solutions, the storage reduction highly depends on the client storage architecture. So in GAF, we have the try, but we also have the flat key value storage. So the flat key value storage, we can definitely reduce like a huge chunk of it, as shown in the example just now. But in other client, like a storage architecture, we may not have that. So in Nethermind, I'm not 100% sure in Besu or in Breath or Aragon. I'm not sure how like pruning this expired state would result in how much benefit. So that's also another thing to look at. So some of the open questions that I would like to answer in the future. So the first question is, what is the percentage of expired intermediate vocal nodes or binary trie nodes? Because if we get a high percentage, that means we can extend this proposal to also prune away these intermediate nodes, which in turn theoretically should also improve the performance. And the second question is, what is the actual storage improvement if we prune the vocal tree? And third question is, how much performance gain do we get from pruning expired state? So comparing this, comparing the before and after pruning expired state in all of the EL clients and see what's the result that we can get. And last question is, how will raising gas limit affect the percentage of expired state? So theoretically, raising gas limit should decrease the percentage of expired state because we are allowing more state access. But it would be interesting to get a number for this. But yeah, and also open to suggestions to see if anyone has any other questions that you like to answer or you think is crucial to answer, and I'll be happy to work on them as well. But yeah, that's all from my presentation, and yeah, Q&A, open to questions. Yes, Gio.
It's a troll, but when testnet?
When testnet? For which one?
For 7736.
Well, I'll have to convince everyone that this is a valid proposal, and hopefully everyone agrees with me, and we can do it on testnet. Yeah.
Yeah. Okay. Thanks. Sorry, that was a troll. But I was also wondering. Do you think that we could get some improve, like if we raise the gas limit, right? We're going to get a lot of churn. So is there like a theoretical upper bound? Like, have you thought about this? A theoretical upper bound of how much a percentage of the state would be? I know this is like departure from what you've done, but I was just wondering if there's in your mind a way to determine that we know for sure that even if we raise the gas limit to 1 million per block, 1 billion per block, we know we would not expire more than so much. I would have to do the math. I'm just wondering if you have done them.
I've given some thoughts about this. I think it's most of the result that we can get is from like a theoretical result, like because it's based on different scenarios. So one scenario could be like a worst case scenario where so let's say we define a period of like 6 months, for example, for a given period, and every single block during this 6 months touches different state, and then when we transition to the next period, then we repeat the state, same state access again. So that would mean that, so this is like a worst case. That means that all of the state wouldn't be considered expired. So because it will be forever like refresh. So so that's one part that I thought about. But on the realistic side, I'm not sure how we can get this number, or I'm not sure if it's even possible to get this number because it's based on real world usage. Some like the data access patterns for different contracts, for example, ERC20 are definitely very different from another type. So I think understanding the data access patterns will be crucial to answering this question, but we'll see about that.
One thing I just realized is, like you said, we could just, if it gets out of hands, we could also reduce the period. Okay.
Yeah.
Thank you.
Carlos? Yes.
Yeah, my question is, can you distinguish if you are expiring an account or a random storage slot of a contract? Like, do you have this kind of information when you're expiring?
No.
Okay. Because the other day we were discussing with Ignacio, and like for Dust accounts and all that stuff, I don't know, but one of the nice things is that you don't need to worry about, like, your account is always there, right? You don't need to do anything. You don't touch it, you leave it there, you come back in 10 years and your account is still there. Is it possible to introduce something in the tree, some marker or whatever, such that we could distinguish between accounts and contract storage slots, or would that be extremely complex?
Let me think about this. I think it's possible. Because like when I was doing one of the tasks, I also faced one of the issue that I face is let's say you submit a transaction, you want to revive a state, but you are submitting a transaction that needs to revive a state. For example, the state is contains the account balance, but in the EL clients, they have to verify using the state, right? So that means it's like a chicken and egg problem. Like, do you trust the balance in the revive transaction or what? Like, or do you get the balance from somewhere else first? So I think it makes sense to maintain some of the information that we have for now. For example, one of the most important thing would be nonce and balance. So it'll be interesting to like extend this proposal, or to consider if you only want to consider expiring the storage slots, because the accounts, I think if I recall correctly, the accounts doesn't really take that much of a space compared to the storage slots. So if we manage to add some markers to the accounts, like we don't prune away the accounts, but we only prune away the storage slots, I think that would make more sense when it comes to user experience. On my mind, I think it's possible, but maybe there are some other caveats that we have to think about. But yeah, I think I'll add this to one of the open questions that we have to tackle in the future. Yeah.
Thank you. And I guess I have one more question. Do you expect, like, where do you expect, like, we will have much more expired stuff? Meaning, I mean, pretty obviously should be in contract storage slots, right? That are expired. But do you think it would go like much farther than we could even anticipate? Meaning a lot of, I don't know, USDT or USDC balances that aren't used in the mappings and stuff like that. Like, how do you have any sort of idea of what we could just remove entirely on the first run?
Yeah. I think. Are you referring to like a very specific state that we want to remove? Like, for example, Uniswap V1 contract that hasn't been used, or is that what you mean? Like very specific
I mean,
state?
anything that hasn't been used for, I don't know, whatever amount of time. Like, what do you expect to be the amount of data removed when state expiry is first, let's say, triggered? Because it's not like, it's not obvious, right? For some contracts, you might just remove, I don't know, some positions in the mappings, but the contract itself remains there. For others that have been completely unused, you might remove the bytecode also and stuff like that. So I'm just trying to see if you have some idea of what would be the complete removal.
I think for at least for now, we do know that we can somewhat completely remove like this 29, so it's like 71% of the accounts. In Verco or in binary will be more complicated because all of the values are interleaved. But let's say we use this figure, so about only 39% of the total accounts will remain in the data structure. So we get to prune away 71% of the accounts at least. So I'll say this is a number that we can have in mind. But in reality, like whether we can remove all of this account, I think that will also depends. Yeah. Oh no. Sorry. Actually, no. Every account, every address should have its own unique stem. So I think in vocal or in binary, it is guaranteed that we remove the 71% expired accounts at least. Yeah. So I think this number is guaranteed. Yeah.
Okay, that's interesting. Thank you.
Yeah. Ignacio?
Yeah, I have a open question to get your thoughts. So one of the things that it's pretty challenging for state expiry in a stem-based tree is how to deal with the hash maps using Solidity, right? Because they basically spread data all over the address space.
Yep.
And we have like a lot of stems with only one value stored there. And I don't know, I kind of was left with the feeling that this kind of pattern for hash maps really kind of creates a lot of noise in the tree for state expiry intentions. And it would be nice if maybe, I know, maybe there's another kind of implementation of hash maps that is more friendly with state expiry. But as far as today, we don't have any kind of incentive for developers using kind of the state tree more effectively. I don't know if you have any thoughts on that.
Yeah, I was looking at the tree set analysis that you have done. I think I had a similar question as well. So the worst case is that the one value leaf node would remain like they are not expired. In the vocal tree or in the binary tree. But at the same time, at least from my result, it's shown that the bunch of stems that are expired. So that means there are a bunch of this one value leaf nodes can also be pruned away. So we are left with like 16.5% of the leaf nodes that are not expired. So I guess I should also find out how many of what's the percentage of this unexpired stems that are one leaf that only contains one value. So yeah, that I think that's another question that I should answer. Yeah, thanks. Yeah. Any more questions? Seems like no more, but yeah, feel free to reach out to me if you have more ideas on this or you want to collaborate on answering some of the open questions. And yeah, I'll pass it back to you, Ignacio.
Cool. Yeah, thanks a lot for all this work, and the presentation was really nice. Let's move to the next agenda item, which is Carlos presenting BlockNet website and metrics gathering summary. So Carlos, whenever you're ready.
Yep, let me share my screen. I'm sharing a locally built version, but should be the same in like minutes. So yeah, so basically just created some site for the whole BlockNet initiative. You have some notes about what the goals are and all of this kind of stuff in the page, so you can read more. But as we said, it's mainly the idea of testing how much we can increase gas limits without crashing the chain. Also having some chain with a massive state so that we can run research ideas or prototypes there and see if they actually are good or not, or useful. And also try to identify any issues when state grows and basically see how we can fix them in advance so that we don't hit that in production. We will basically be adding all of the findings that we have. This is just an example. It's not a real use case, but the idea is that you will be able to see like at which size, which client specifically had an issue, and basically the analysis of the whole issue itself. And if it's fixed, you will also get a link to the PR that does it. So then we have a metrics side. On the metrics side, I basically have included all of the metrics that the teams have shared with us. This is just a short description of the metric that they want. Ideally, being persuading, I don't know how to say it, but I'm like behind the teams constantly trying to get more metrics, because at the end they are the ones that build the clients, so they have much more insight on what is interesting to collect and what not. My intuition is that any data that it's non-reproducible, so basically ephemeral, it's important to be collected if it's related, of course. So that was my educated guess. But so far we've had input from Geth, ourselves in Stateless Consensus, Besu, and some small stuff from Eridon. And of course Nethermind. I will be adding those shortly here. The idea later will basically be to make sure that as many teams as possible have the capability of collecting such metrics, and not only that, but also try to expose them in some Grafana, so that basically anyone can see how the network is behaving under stress. There's also forms in basically all of the 3 pages. So basically for anyone to actually submit new metrics that they want to collect, or to submit attack vectors or plotting vectors. Just ignore the text. This is just some stuff added for now to have some columns to be used. But basically the same idea on the attack vectors and scenarios, just trying to guess what things we can run in a transaction that can maybe stress nodes when we are in, let's say, 100 million gas chain that has 1 terabyte of state. And also some like more miscellaneous attacks, which will likely require either raw database manipulation or some more complex structure to be set up. And finally, we did some research on how to bloat the state at the maximum rate possible. Some of this stuff needs to be recomputed, let's say. But we have actually built the scenarios for case 1, 2, 3, and that should be it, right? Yeah, 1, 2, and 3, which are the biggest ones, and they are the ones that contribute to everything. So accounts, bytecode, and also storage slots, both in the EO smart account world and also on the smart contract world. So this is so far what we will be using together with Spammer to actually spam the network as much as possible and try to see if we can break some clients or not. Same form as always, and that should be mostly it. I want to first say thank you to Nethermind, because they are also helping a lot and moving a lot of stuff to basically make this initiative work. They are setting up the network. They are running a bunch of stuff to do that. So shout out to them. And also I would appreciate if Karim has been already helping on that. But if there are teams that want to contribute to any of these 3 things, we will highly appreciate it, especially on metrics and attack vectors, because running these experiments will be expensive, and it's not immediate. It requires a lot of time and time investment from people, and time in itself to run those things. So the more we can capture with every run, the better. And yeah, that should be it. Thank you very much. And if you have any questions, happy to answer.
I have shared the paper. If anyone want to like give a look on it, so like we can discuss, or we can discuss in next meet, like for the agenda.
Does anybody have a question for Carlos? Okay, so that's the last item in our agenda. I don't know if anyone else has some kind of last minute thing to discuss. If not, we can wrap it up. Okay, so I think that's it for today. Thanks everyone, and see you next time.
Thanks.
See you
Cheers.
next